So let's look at these methods a little more in depth so you kind of know what they are when your children get these tests that are in your classrooms. Event-related potential is a recording from scalp electrodes. You've probably seen those caps that have all the little electrodes on them. They can have as little as 3, as many as 40 to 50. Of course, the more they have, the more sensitive they are. And they look at the nerve response to a sensory or a cognitive challenge. So the participant is given some kind of something, a click, a face to see, and you look at how long that it takes for the part of the brain that should be reacting to react. You look at the pattern of where the brain is reacting, what's lighting up, what's using producing electricity at that point. So it reflects the activation of the nerve circuitry in the brain, and it creates a waveform that really lets you know in time and space how it's working. It's really good in time, in temporal ways. So here's the stimulus and here the brain react. It's not so good spatially, because even if you have a lot of electrodes, the electricity may travel to the scalp that is farther away from where the actual site in the brain is being used. But certainly ERP has given us so much information, because it allows us to see a brain that's functioning, that's doing something, not just the structural information you get from someone who has passed away. Then we have CT scans. This is a series of detailed pictures of areas taken inside the body from different angles. So the pictures are created by the computer, and it's linked to an X-ray machine. And then we have PET, or Positron Emission Tomography. And this is a procedure which there's a small amount of radioactive glucose injected into the vein, and they use a scanner to make a really detailed computerized picture of the areas inside the body where people use that glucose, or where that radioactive glucose is being used. Then we have an MRI, magnetic resonance imagery, and these are radio waves, and a powerful magnet is linked to a computer, and it creates a really detailed picture of areas inside the body, and these pictures really show the difference between normal and diseased tissue. So it gives you a more detailed picture than a CT scan. fMRI, functional magnetic resonance imagery, are magnetic fields associated with processes like blood flow, and they're really used to look at functioning. So what are the issues depending on the methodology? One of the things that is really a problem is that with our current methodology, it's very difficult to look at the interdependence of functions. So you may just look at one section of the brain, how it lights up, or another section, and so it's hard to look at how all of them work together. It's very difficult to compare what you can get from looking at something structurally to look at that in addition to chemical function, in addition to other functional components working all together. So it may be the gestalt that gives us the real information, but right now we have some simplistic conclusions because we don't have the technology right now to look at all of those areas. For instance, chemical differences, if we're just studying chemical differences, may be indicative of underlying structural differences or caused because of underlying structural differences. But if we're not looking at both of those together, we won't know that. So furthering our research in this area is really critical, and I think huge strides are going to be made really soon.